I'll be honest, when I first saw the Signals proposal, like, to your point, like, everyone does it. Why do we need this to be a top level, like, Signal class? The one thing that this can do at a language level that we can't do is good garbage collection of signals. So if I have a signal that is subscribed to another signal, so A to B, but nothing's pulling from B, B can't be garbage collected. It still exists in memory, and it'll still hold on to its memorized value indefinitely until A also goes away. And if A is subscribing to something, until that whole chain goes away. Oftentimes in a like complex web application, that's fine, because once your UI unmounts, all the signals are gonna go away as well. Or maybe not all of them, but a good block of that chain, but not a blockchain.
No, not blockchain. Chandler's back this time, and he's talking about a stage 1 JavaScript proposal called Signals. Every high-level framework like React, Vue, Svelte, Astro, and Solid already has their own custom reactive programming primitives for state management, but Signals hopes to standardize them. It focuses on efficient state management, dependency tracking, and lazy evaluation for UIs, and a lot more that will reduce boilerplate and unlock a really great developer experience with great tools for the whole ecosystem. If this proposal makes it, then libraries can share a unified underlying state management mechanism, which suddenly gets you interoperability for any framework like React, Vue, or whatever else. Then near the end, Chandler shows it in action in a project that uses Signals and web components together. And one little last thing, a quick apology. So Chandler gave this talk here live in Michigan on May 7th, 2024, but it's taken until now, the second week of December, to get it posted. It was an all-hands-on-deck affair to get SquiggleConf to happen in October in Boston. That's our excuse. As well as another very exciting project we've been diligently working on in the shadows that will see the light of day early next year. All right, so we hope you get wicked hype for Signals and cheered on to TC39 Stage 2.7.
Hello, thank you. It has been a while since I did anything like this, probably 5 years, so forgive me for all the ums that I will inevitably sneak in, like that one. My name is Chandler Prawl. Do you want to track me in any way? Please don't. But if you want to follow me on social medias or anything, my handle is always Chandler Prawl, and that is me. I've been doing some kind of web development for about 20 years. Got started in high school, just fell in love with the web and especially front end, the ability to just open up Notepad on my computer, type, save, refresh, and it just showed up in the browser, captivated me, and I've been involved ever since. Tonight, wanted to talk about three things. First one, Signals. If you don't know what it is, that's totally fine. We'll talk about it here in a second. But it's been big keyword in some parts of the front end or web tech area for about 2 months now. Web components has been around for a few years now. If you've looked into them, you either love or hate them. If you haven't looked into them, you probably have heard that people either love or hate them, and usually not too much love. And then lastly, a side project that I've started working on, as I shared with Dimitri, and he said, hey, you should come talk about that. So here I am. All right, we'll get started with some signals. If you don't know what those are, if you know pub sub, like publish, subscribe pattern, observables, or any kind of state libraries, you're familiar with what a signal is. Or according to ChatGPT, signals are a way to handle state changes and notifications in front-end development. I did not ask ChatGPT for this. I asked it for an outline, and it told me this instead. So here we go. Start with 3 examples. The first one coming from RxJS, so an observables pattern. We're going to import from event and scan from it. From event, just saying, hey, when there's a click on document, that's a signal. When that signal happens, pipe that to the scan. It's going to just create a count of these clicks. It pipes that signal to, or gets subscribed to, basically an effect. When count increases, log that out. Similarly, if you're familiar with MobX, which is a state management library, I think probably most popular in the React community, but it is a standalone. You can use it just by itself or with another Vue library as well. Here we're creating the counter as well. The counter store gets created, it's tracking its count. But this make observable call that's about in the middle is where MobX comes in and its power can shine and where all the power happens. We're saying that this count value on the counter store is observable, and that the increment function on the counter store is an action. And it's got this auto run. So it's saying that like as things happen and as changes happen in the system, run this automatically. And this is just log the count. So we can see when counter store is created. I don't know actually if you can see, well, yeah, there's a comment 0 here. Like initially things just get kicked off. It's going to log out the initial value. And then as increment is called, it logs out 1, 2, it's a counter. It does its thing. It's a signal. When increment is called, count the observable, the signal triggers that auto run and gets logged out. Lastly, any kind of React hooks, almost any kind, useRef doesn't count. Anything that really has a dependency array that'll trigger a re-render of your component, that's a signal. It's just saying when set count is called, trigger the whole component again with the updated count value. With the use callback, anytime set count changes, which it can't in this case, but if it did, it would re-trigger based on that signal coming from use callback and the whole component re-renders. Benefits of Signals, kind of that FP style, functional programming style for, in my opinion, good developer experience. The code helps align to your data models. I've seen so many applications, it's just like spaghetti code, just trying to keep track of the data and what is the state, what does that look like. If you approach it with a reactive, signals, observables, any of these kind of patterns that help push you towards writing your code and structuring your application to meet your data where it's at, instead of writing your application to not match your data. That creates just, a horrible mess. It creates isolated updates. Sorry, it doesn't create. Benefit of Signals, they create isolated updates, which I'll go back to the React. React is kind of bad at this, right? There's actually three signals for the counter here. It's use count. Again, I said the use callback, which is iffy in this case. But then also like wherever this component is used and being consumed, it has a parent signal coming into it. So there's actually three signals here, not well isolated. And so anytime one of those three signals change, this whole component will re-render. But if we go back to like the RxJS example, that subscribe, it's coming from that event, it's being piped. There's just like one continuous source for that signal propagating through. And so that's a big benefit, that you can have isolated updates. Your whole app's not going to re-render just on one value change. They can also be optimizable. So you can cache values that have been seen through the system. You can compute things on demand. Let's build our own. This image was just part of the background for this slide, the deck that I picked up, and let's go with it. Let's build our own, see what happens. We're gonna start at base class. At the top, we're just gonna signal, hey, it's TypeScript, let's bring in generics. We'll hold some kind of value, whatever it is, it's T, have a private listeners array so that only our class instance can access it, other classes can't. We're gonna accept listener, be able to unsubscribe if we want, emit values, and those values, when they emit, we'll just call the listeners. And that's a signal. That's a signal. But let's add on to that. Let's start storing the value. So we have a new parameter called value, storing that value type. We'll accept it on construct. We have this new set. Instead of emit is gone. We're going to set the value, restore it, but it's the same pattern. But now we're just stored it on the objects. We'll add a little developer experience here, at least for me. I don't like that direct value is there. I like a little more magic in my APIs. So we'll have a getter for value. It returns the value. It's just now a private member on that class. And when we set value, we'll set it, store it, and call those listeners again. But now instead of saying counter.set at the bottom, we're just assigning the value, and it calls that set value function. Let's look at chaining. So the RxJS example is great. You say, this is where my signal source is. It was that click listener. When it comes through, we're going to count those values, and then we log them out. It's a great chain. In this case, it's not so great with the signal that we have, because we can create two signals, and then we have to manually do that work to chain them together. So let's make it so that our signal class, the value, can be set to a source, and it'll propagate that through. So set value is now no longer just setting the private value and then calling listeners. It says, hey, is this a signal? In that case, I'm going to steal your value. Steal, borrow, propagate. And then when you change, we'll update this value. And then again, call the listeners. And so the example on the right, in this case, we've lost our count though. We have to-dos, we have a count, but it's just taking that value. It's not doing anything with it. So we'll add a transformation in. When we call new signal, we can say where it's coming from and provide a method that says, hey, in this case, grab the to-dos and just return the length. A couple changes to set value. We've taken that emit, the calling the listeners out. It's now only in the propagate function. We're going to call that 2 times here at the end of any time the value is set, or when its parent, its source signal changes. then we're going to call that propagate out. But still, that's all we're doing. We're going to store the raw value in the member class, and then on that get value, right? I like kind of those magic API functions, just a little bit of magic. We're going to transform the value at that point. We could go further. We could store the transformed value and just memwise or cache it. Maybe it's a really expensive operation, transform the value. In that case, we would need a way to like mark it dirty. So when its value comes through, we would mark it dirty. Then on the get, we could recompute when it's dirty. Otherwise, just return that memoized value. You can keep layering in additional properties, things that you can do with signals. But at this point, we've got a pretty solid signal class, at least enough to continue on with the presentation. So I mentioned the signals got kind of big and popular about 2 months ago within the front-end web community because 2 people came by and proposed that there should be a top-level or like browser-native, JavaScript-native, not just browsers, signal class. They said they were inspired by the success story of Promises or A+, which is where, man, what was this? 8 years ago? I'm getting old. If you had a promise or a promise library, it wasn't necessarily going to work with the other promise or the other promise library in your application or another one. There was a plethora of ways to create promises, to have venables, and it was a mess. Bluebird was probably the biggest one, and it had a lot of extra features and functionality as well. The JavaScript community came through. The TC39 committee, who kind of oversees these proposals and shepherds them through and gets the changes into ECMAScript or JavaScript. They said, let's see if we can clean up the community. This seems to be a valid pattern, something that is really good. And of course, after landing, Node was able to take that, change a lot of the APIs. So instead of having a callback for their APIs, you can now have async. And then that led to actual async and await. So this proposal inspired by Promises and the success story there. These folks are seeking a common pattern to abstract to, similar with the Promises. All the Promises was a .then. There was some way to resolve or reject or cancel. So they're looking to do the same things with the signals. Let's look at RxJS. Yes?
So is the idea that React and Vue and other libraries would afterwards, I mean, after this proposal goes through, if it does go through, is the idea that they would rewrite the internals of their libraries to use signals under the hood, like a signals class that's now provided?
Yeah, basically. So the third bullet point here, allows sharing signals between libraries, is the key crux there, right? If I can take my observable from RxJS with a JavaScript native signal, and I can just give that to my Vue component or Angular or React or whatever, and just like, hey, RxJS, when this happens, my React component updates automatically. Like you can imagine like a use signal hook in React, right?
I guess I just don't understand why that would be good, because it's like you don't have a situation where you have a Vue app and a React app at the same time.
I don't. Some people do. I don't recommend it, but not necessarily mixing your Vue frameworks, but allowing the compatibility and cooperability between the different frameworks within your application.
Oh, okay. So then I could use, okay, so then if like React query rewrote their internals to use signals, that means the React query dev tools would be usable in Vue easier, or some other framework with some other framework because, okay. All right. So it's less about the high level frameworks like React and Vue and whatever, and more about like the whole ecosystem of tools using the same, well, I guess just like you said with Promises. Okay. All right.
Exactly. Yeah.
Okay. Thank you.
Great examples. Like React Query is a perfect example. Right now you have the React hooks into it, and it has whatever, I don't know, its internals, however it triggers that state to update. It could just be like, here's the signal you asked based on this query key. Here's your data. It got updated. Right. Absolutely. And then you could just take React Query and drop it into your Angular app.
I think I'm just jaded because it took so long for so many of these libraries to get on board with the Promise built in. You know, they were using Bluebird for, I mean, you remember, Ian, how many years? It's like years and years and years.
Yeah.
Libraries were still using Bluebird internally, and it was a painful process. But I guess it is over, and I can't think of one that is.
I think it's probably more the new next generation of whatever would get built on this and then end up superseding, would be my expectation. we know there's a pattern. There's a common pattern, and we can see if there's standardization.
I think a lot of like the next generation has been doing that for like 2 years now.
Oh yeah,
You know?
absolutely.
It's not, yeah. So like put a stamp on it and, you know, drop a cert, and because everyone's already doing it, right? I don't know. That's how I see it.
Except that yes, pattern-wise, but everyone has their own like signal class or way of communicating it, which is also like fair and fine. Because like, who doesn't like? Okay, probably a lot of people. I sure like to take a built-in class and extend it and add on. Because like a signal, like I could sidecar like a message bus channel on it. So one actual problem with just signals piping directly into like React or Vue is, what if I have an array of items and I insert something? Now, if I emit that array as a signal and say this has changed, my application doesn't know which item in that array has changed. Let's say they're just complex objects, and I can't do necessarily strict equality checks on them. React gets away with this, gets around it rather, by you add a key onto your element that's returned from like an array.map. And so it knows this element was, my key was 2, now I see 2 is down here, I'm just gonna shift the element instead of unmount and remount all those components. So I can imagine like add a message bus or something onto a signal so that it can pass array operations down and the like memoized array object itself. And so if your consumer of the signal knows how to process the array messages, it's just like, oh, you pushed an item, I can do that. If I don't know how to do that, I have a new array of things and I can reprocess. That is not part of the proposal. That's my proposal on top of it, how I would extend a signal.
So useEffect is a signal?
Oh, great. That was going to be the hidden bullet point at the end of this. useEffect is the effect, the side effect from a signal. So on here, or anywhere I had an on, would be effect. The proposal itself includes a polyfill, so you can grab their proposal, their signal, and just play with it. Developers from Svelte, from Preact, Angular, I think it was MobX. Like there's 10 different projects, big name projects, who are involved now with the proposal to contribute ideas back and things like that to work in that capacity. And so there is a full, a working but not prod-worthy implementation of a useEffect. And it's basically, you have a signal, there's a signal and there's a computed signal class for the proposal. For the computed signal, it just calls your side effect function on change, which to me feels a little weird, but that's how they have it structured. But that's what an effect is. It's just like, on this value, do this thing outside of the signal ecosystem or signal graph.
So there's a signal under the hood, is what you're saying? For
The
useEffect?
signal's all the way down.
All the way down, okay. Is memoization, is that a signal or effect of a signal?
It is a member of, or it is a conceptual property of a signal, so that when a signal receives its value, it changes, it does its computations, and then it stores it locally on itself and passes that down.
I see, okay. Yeah, I got, okay.
Exactly.
That makes sense.
The one thing, so I'll be honest, when I first saw the signals proposal, like even still a little bit, like, to your point, like everyone does it. Why do we need this to be a top level like signal class? The one thing that this can do at a language level that we can't do in just JavaScript, the community space, I forget what the term is good garbage collection of signals. So if I have a signal that is subscribed to another signal, so A to B, but nothing's pulling from B, B can't be garbage collected. It still exists in memory, and it'll still hold on to its memorized value indefinitely until A also goes away. And if A is subscribing to something, until that whole chain goes away. Oftentimes in a like complex web application, that's fine, because once your UI unmounts, all the signals are going to go away as well. Or maybe not all of them, but a good block of that chain, but not a blockchain, goes away. Because you have that listener, when you subscribe, you say, hey, A, when you change, let me know. And that me then exists in that graph, and so it can't be garbage collected. But at a language level, it could say a signal does not have a strong reference to its source. Rather, the source does not have a strong reference down to the consuming signal, and that whole, as soon as it's B is done being subscribed to, the JavaScript engine can collect it away. That was probably a terrible explanation. If you have questions, please ask. Lastly, someone mentioned like, yeah, I think it was you. Could you have a React signal or something and like see it in the Vue dev tools? Like, yes. If these are all a signal object, I don't know why you would want to, but like, yes. Like tooling, the investment into dev tools can be made on one class of object across all the browsers. And then it doesn't matter what framework you're working with, what their object is, what their classes look like, you'd get it. And you get those browser internals too that can be added onto them. So timing operations, how long did this one take to compute? Can we visualize that whole signal graph as well? All right, on to 2. This one's pretty quick. Web components, they're reusable, they're browser native. Benefits, they're browser native and they're reusable. They can extend existing elements. So if you've ever wanted to change how the input element works for some reason, which I do later, I just log, you can do that. There is shadow DOM. That just means, well, if you think about an input with a type of date picker or input type of date, you click on it, the browser will open up a date picker that it has, but you can't inspect any of that content in the dev tools. It's just hidden away. It has its own internal shadow DOM. So when web components were introduced, they were like, we already have this concept. Like sometimes you can see that the DOM or the elements that the browser is rendering, sometimes you can't. And that concept got exposed for web components. You can opt into it being closed or, versus open. So when it's closed, you can't inspect it. When it's open, it can be inspected. You can interact with someone else's web component and its inner DOM from anywhere in the application from JavaScript. But really what it opens up with the shadow DOM is either open or closed, is you get scoped CSS and scoped events for just free. If you throw a style tag inside a web component, it'll only style the content of that web component. It won't escape to its parent, and it's the children that are passed into that web component either, or passed into the web component won't inherit those styles either. Events, right? You can emit custom events. That's not new. What is new is that when you create a new event, there's a new option. Top of my head, it's fine, and they use true or false, whether it escapes the bounds of that, continues to bubble up through the rest of the DOM, or if it's scoped just to your component. So you can just fire click events all day, but they're not going to escape your component, and you can collect them yourself. Lastly, benefit is slots, which we'll see in a couple slides, but you can effectively have multiple types, categories, targets with the children that get passed into a web component. So again, like React, probably obvious, my background is React, you get an array of children or one child or an array, and you have to like look at them and like inspect the internals of the React object that represents that child to look at things like its props and things like that if you wanted to treat them differently, which you shouldn't. But with slots, you can just say, hey, anything tagged with X goes here, anything tagged with Y should render over here. Downsides, there's quite a bit of boilerplate overhead, and it requires JavaScript, which, I don't know, you can't server-side render web components, at least not right now, that I've seen. But like, who's server-side rendering their app? You should be, but who is? So let's get in. We'll just take a look at a couple examples for web components. This is the boilerplate that I mentioned. Like, this doesn't do anything. In fact, this will error because unless you have a template, there's a template element, template tag, and the recommended approach is you have a template tag that like has the HTML that your web component's going to use. You read it from the DOM, you clone it, nested, and inject it that way, which is, it's an approach. But yeah, this is the boilerplate. We're going to define my element. So that's the tag that you would use. It's just left caret, my element, right caret, children, close it. Pass into class. It has to extend HTML element. If it's going to extend something like the input element, there's a whole different way to do that. As an optimization, you have to tell it what attributes you want to use and observe, which get used later on at the very bottom. We're going to construct. On construction, we obviously call it the constructor for HTML element. We're going to create that shadow root. In this case, it's open. We're going to add to that shadow root whatever was in that template. And in this case, I just showed like, it's a class. You can like interact with it. The shadow root's kind of like a document fragment. And a lot of those just common element APIs are available right on it. There's 4 built-in lifecycle methods: connected callback, which is its mount, Disconnected callback is unmount. Adopted callback, it's moved to a new document because, JavaScript. It doesn't you would be intentionally moving it, but there's lifecycle hooks because of that. And then, like I said, if in this case color or size ever changes, if they get added, if they're removed, your attribute changed callback is fired with that new and old information. So kind of like a built-in mutation observer. Important to note that attribute change callback will only be called based on those observed attributes. It's an optimization thing that if something's just adding data test IDs to your elements left and right, you're not going to get a callback. But hey, let's customize, in this case, the P or paragraph element. This is lifted straight from MDN. And when we are extending an existing element, you have to tell it what the tag name is, but also the class, the base class from it. That annoys me terribly because why doesn't it just know? But you have to do that. And then you get to use it with that element, and then is equals that definition that you provided. In this case, yeah, whatever you want to actually do, you would go in there, but you get that element. Obviously, you get access to the DOM from the element. In this case, I don't know, read the text content, count the words, and console log. Maybe a tooltip. All right, slots. Slots are actually cool. So in this case, we have my list. It's in an HTML element. And then just injecting this inner HTML into it to render real quick, so I didn't want to deal with templates. And I have an unordered list with a slot and that li in there, just nothing to list. So that top right screenshot shows, hey, it's an empty list. We fall back to the slot default. Otherwise, we have the list of the elements that were actually passed in. And there's JavaScript and CSS APIs around knowing what's in a slot, what changed. You can even tell it that all of this is going to be manual, and you'll keep track of what is in a slot yourself. And then CSS rules to target things that are slotted, things that are missing items, etc. There's also name slots. This is what I was talking about with this children, multiple types of children. So in this case, we've added a strong tag. The slot attribute there is title, and then that same UL default as before. And now when passing in my list, we can do li. I mean, you can do spans. It doesn't have to be li. It's just any element there is going to go into that default slot, the unnamed slot. And then we pass in the title here as a span, but we call it out slot equals title. I did not update this. I'm sorry, there's a bug here. This is a slot, not a strong tag, and a name of title. And I just did not update the screenshot. But you can, therefore associate getting this over here is right. So slot equals title would match name equals, slot, name equals title, yes.
So is this how some of the magic HTML attributes work in Vue and Angular and a couple in React? If I do
I don't know the internals
whatever
for Vue or Angular. React does not do anything with web components, period. Web components was meant to be built on top of by frameworks, not to be used directly, which is why that boilerplate, it's a mess, but it's okay, it's powerful. All right, so tying both of those concepts together, this was actually going to be my main, almost entirety of my talk. And then the Signals proposal came out. I was like, okay, there's an additional hook for content there. But why? Why should I start a project? Me a few years ago, when the React specs decisions was not care about sets managed state, I would update this to be one of the React specs decisions was to focus on rendering in the browser and just render. Please just render. Me a couple days ago, React, by introducing hooks, has made it way too easy to not focus on the separation of concerns correctly and be concerned with just my component. But now with hooks, in my opinion, far too easy to do the wrong thing inside your component and not split it off into a service, to not use your application frameworks and libraries. But React just wants everything to be composable. So then you could take this component, ship it to NPM, and it will just work for someone else, which is nice. But if you look into it, it's called React Query. It has these other use and hooks that it has, and you don't know what it's doing, which is bad for you, bad for your users, because now your application could just chug after you hit a button for 5 seconds and you don't know why. Or, even if you figure out why, it's downstream 3 libraries and you can't do anything about it. So I wanted to start my own project on top of web components. I had looked at web components twice before, So I was like, okay, from the ground up, I'm just gonna learn web components. So I started with a tooltip and then went to to-do list because no web project is complete with a to-do list. Created a little login form because that's where I learned that you have to do weird things to extend the input control components or elements. For example, if you just have your own web component, because of that shadow DOM, if you have an input in there, right? If you hit enter, it's never gonna propagate that up to the form. It's never gonna trigger like form submit events. And so you have to actually set up your custom web component using that, in this case, to be input is equals whatever your web component name is for that functionality. And then it just magically works together. But learning those intricate details was interesting. I built a calculator that was mostly around events. And then I built a full desktop application because what better way to iron out the wrinkles, the bugs in your framework than build draggable windows. Yeah, so that got repurposed into Vena. It's Latin for artery or something like that, or vein, which to me seems like, yeah, signal. Your veins are taking nutrients to your cells. I'm taking data and putting it in your views. This was my goals, sorry. Stay in JavaScript land, avoid new syntaxes and concepts, provide powerful tooling that stays out of the developer's way, and as much as possible, no build step required. So what does this look like? I have an element signal from Vena.js core, which is freshly published today. I was scrambling. I create a new counter. That should look familiar. It's a signal, more or less the class that we built earlier. And then using tag template literals, there's this element, tag template literal, and it's just HTML. But then when you want it to use not just HTML and inject a value or a signal or something, just do so. And that just works. Moving on to actual web components, making it reusable. There's a register component. You give it the element that you want to use for that component. You get a few functions and objects back, in this case, render, attributes, and refs. We're going to pull type and rest and the rest of them from attributes. Type gets put on the input. The rest, there's no spread like in React with JSX, but you can just still pass all the rest of the attributes on wherever you want. Again, just refs are automatic based on the ID right here, input. It gets automatically mapped to that object, and it just works. Eventing. So before I mentioned if you have an array and you're modifying it and you want those values to get pushed down as you're making those changes, a lot of the signals libraries out there, you would need to push a whole new array to, or thinking to like React, if you're going to set state and you're managing an array, you have to create a new array as you call that set state when you're passing that array into it. Otherwise it says like, oh, this array that you're giving me is the exact same array that I had last time. I'm not going to do anything. You're a silly person. Don't tell me to do the same thing I just did. So you have to just spread the array values into a new array as you're setting that state. In this case, going to our signal, you'd be like signal.value equals signal.value or somehow to trigger it. So I created a proxy signal object that just takes an object, in this case an array, but you can continue to operate on it. Yeah, I didn't in this case, but you could have to-dos and you could do to-dos.push. And it just knows that that array method exists, it's proxied. And then it, on any property access after the operation happens, it'll re-trigger that signal. But anyway, for the events here, we have the to-dos on new item. We're going to list them out, the to-do items, passing through to those slots. And then there's a event for a new one that comes up. I'll be honest, I'm not sure about this API. I don't particularly like it. Emit here is just new item, and that's automatically tagged with to-do list, new item over here with the on in front of it for a handler. It feels a little too magical to me, but that's how it currently exists. But you could also it's just JavaScript, right? Instead of doing a custom emit, you can grab the element, call what is the dispatch event, pass in your custom event, and just do it all yourself too. So just small wrapping some magic on there. That one I'm not sure about. Context, state, and live reload. Live reload's first, that's the first line. It just works. You have to have, there's a live reload server component to it. Again, this was no build step, so this is not using the live reload that is used by Vite or Webpack or anything like that, although I plan to support those as well. But this is just, it's a file watcher, and it just emits the events to over the WebSocket here. Let's see, we're looking at context, state, and live reload. All right, so context is easy. We're just going to define a symbol just so it doesn't collide with other contexts, and then we can use it. We got context from the object structure. We can write to it, and we can read to it. This one on reading is not what we just wrote. It knows to skip the value that we wrote and just look at the DOM ancestors for its context. And then state, in this case, comes into play. Because of live reload, if you were declaring a new signal inside for isDragging, just right here inside of the register component, every time it gets live reloaded, it would drop your current signal value. It would just throw it away because it doesn't know about it. So I added the state value that comes through. It's a function you call it with the defaults, and then it'll persist that it's useState from React. It was amazing to me going through this, or it's probably whatever state thing is and pick a library, but I'm mostly used to React. It was interesting to me as I was putting these together, like how many concepts I came to more or less the same API design for as React. But to me, it's like as soon as you start seeing the complexity here, that's when like, oh, I'll break it out into different components. Whereas with React and other frameworks, they're like kind of embrace the complexity now. You can like use 10 hooks and it'll just magically like put those signals in the right place and cause the full component to re-render all the time instead of isolating everything. And it adds JSX support. If you want to have a build step, why not support JSX? So element and that render callback from register component, both support it out of the box. It's nice. One distinction between regular HTML and anything from JSX is indentation, that white space in HTML, collapses to a single white space. JSX, the indentation, just collapses away altogether. So you can have very small differences if you are before React, before server-side rendering of React was a big thing and easier to do. You would write your HTML templates in pick something, Java server pages, PHP, whatever. Then you could have your React application on the client side, hydrate the whole app by like re-rendering the entirety of everything. It was an actual hydration, just rewrite everything. And when there was these white space differences, you'd have very small layout shifts as your React application mounted. Wasn't a big deal, but like it's annoying. And so, just calling it out. It also impacts slots over here, especially the default ones, because your white space, I put it all in one line to avoid this. The white space, when setting the values, or not using it here, sorry, but, oh, I didn't actually have the code. Oh, I do, yeah. So that indentation on the right side, if I just had the title here and not these other items, this white space would become my default slot item, which is not obvious. So that's another gotcha with web components and slots. But JSX is helpful and just abstracts that away. JSX throws that white space away, doesn't abstract it. And then another powerful feature here. So again, extending a component, this case is input element. If you hit the enter key, it just logs enter. Instead of saying input is my element, we can just import my input. Well, in this case, it's just defined here. But we get back from register component enough information that it will know to structure it appropriately when rendering that out to the browser. So it does all that lifting for you. There's just some annoying setup to work with web components in that capacity. Also, yeah, did it here. Similarly, if you're familiar with React or JSX and TypeScript, it is kind of annoying to define, JSX intrinsic elements and intrinsic attributes. So there's a Vena namespace with an elements interface. You just extend as you add components, and then those just get type checked. So message here always exists. It's a string. So when I go to use it from that attributes object, I know the message exists. It's automatically transformed into a signal of string for me. So the incoming value could be a signal. It could just be a string that gets managed for me. Extended element, and then yeah, some demos. So for example, that desktop. I've got a terrible internet connection at the moment. There's my background. I can open the README. This loads a Markdown renderer. There's the actual README. I have apps. I can go wild. It'll even live update. So this was, again, ironing out the wrinkles, both programmatically, functionality-wise, but developer experience as well. Kept running into like, oh, it takes me 20 lines of code to do this thing. It shouldn't. How do I optimize that and make it better? A couple others I did. I'll jump down to the last one. I was inspired. There's a Free.js is a probably the most popular, well-known WebGL rendering library. There is a React project for it that you can. Let's see, what is the shortcut for view source? Yeah. So this is just, instead of JavaScript, we're just rendering out HTML elements. These just build up through the context and render, in this case, the cow and the pig at these locations. And then we're turning every render of the screen. This is based on the idea from someone else who built this, but much better for React with Three.js. So definitely stealing their thunder there. And then I wanted to try another actual web application-ish kind of thing with drag and drop. Oh no, it's probably Wi-Fi. This might be a me thing. Oh, this is a me thing. This was me scrambling this afternoon to actually publish things. Yeah, but there is a drag and drop version as well. You can add cards, markdown support as well. So just me playing around with ideas. If this looks cool to you, let me know. I'd love to learn use cases and improve it in any direction. Otherwise, I'm just going to continue building my own web stack and cheap version of the tan stack and see where I go from there. So thank you very much.